In this section, we discuss a method of evaluating integrals. This method is called substitution method. We apply this method if we have some function and its derivative or part of its derivative. So if the integrand consists of a function and its derivative or part of its derivative, then we can use the substitution method. So for example, we may see a problem like this. The integral of 3x squared times square root x cubed plus 1 dx. Here we have a function x cubed plus 1 under the square root and its derivative 3x squared. So we use the substitution method. Or we may see something like this: 2x integral of 2x times x squared plus 1 all raised to power 2. Here we have a function. The function here is x squared plus 1 and its derivative is 2x. Also, we may see something like this: 3x e to the x squared dx. The function is x squared and its derivative is 2x, but we only have x here. So that's part of its derivative. So we know that we can apply the substitution method. Another problem that may be solved using substitution method: natural log of x over x dx. The function is natural log x and its derivative is 1 over x. This is the derivative. Now, keeping this in mind, we can apply the method on a wide range of problems. The idea here is that we use substitution. It's called substitution method. So we need to use substitution to simplify the integrals or the integrand. Integrand is the expression inside the integral. So for example, the integral of 4x times x squared plus 1 raised to the power 6 dx. Now here we have the function is x squared plus 1 and its derivative is 2x, but we have x here, or actually we have 2x here because 4 is 2 times 2 times x, so this is the derivative of the function. Now, how to apply this method? First, we use the substitution. U equals this original function x squared plus 1, or this main function. And then we find the derivative of this. Derivative of u is du. Derivative of x squared plus 1 is 2x, and then we multiply by dx. Then we solve this for dx. dx is du over 2x. And then we plug this into the integral. So the integral is integral of 4x times x squared plus 1 is u raised to power 6. Now dx is du over 2x. Now, after substituting these, we should eliminate all x's from the integrand. So we should eliminate all x's from the integrand. So we still have x here, but we can cancel this. We can cancel x with x and 2 with, we can simplify it with 4. We get 2 here. So this becomes integral of 2u to the power 6 du, and since this is constant, we can bring it out of the integral. It becomes 2 times the integral of u to the 6th du. Now, what is the integral of u to the 6th? It's u to the 7th over 7 plus c. Now, is this the final answer? No, because the original function is written in terms of x and the answer is written in terms of u. So we need to use the substitution again to rewrite the solution in terms of x. So, but we know that u is equal to x squared plus 1. So the answer is 2 over 7 times x squared plus 1 raised to power 7 plus c. This is the final answer. Let's do another problem. If we want to evaluate the integral 3x e to x squared dx, Now the function is x squared and its derivative is x. The derivative is 2x, but part of the derivative is x. So we use the substitution. U is x squared, and then we differentiate this. Du is 2x dx, and then we solve for dx. Dx is du over 2x by dividing by 2x. And then we plug these into the integral. We have 3x e to x squared is u times dx. Dx is du over 2x. Now we simplify, so we can cancel the x's, and we get 3 over 2 times the integral of e to the u du. But we know from the previous section that the integral of e to the u is the same. It's e to the u plus c. Now u is x squared, so this is 3/2 e to x squared plus c. Another example, the integral 1 over 2x plus 5 dx. Now here we have the function 2x plus 5, and its derivative, part of its derivative is 1. Its derivative actually is 2, but this we missed 2 here, right? So this is part of the derivative, because the derivative can be 2 times 1, so 1 can be considered as part of the derivative. So we let u equals the denominator 2x plus 5, and then du is 2 dx, and then we solve for dx. Dx is du over 2. And then this integral becomes the integral of 1 over u times dx, which is du over 2, and this is 1/2 the integral of 1 over u du. But we know from the previous section that the integral of 1 over x is ln x, ln absolute value of x, and same thing here. The integral of 1 over u is natural log of absolute value of u plus c, but u is 2x plus 5, so this becomes 1/2 natural log absolute value of 2x plus 5 plus c. If we want to find the integral x plus 3 times the square root x squared plus 6x dx, now the main function is x squared plus 6, and its derivative is 2x plus 6, so this is part of its derivative. So u is x squared plus 6x, then du is 2x plus 6 dx, and then we solve for dx. Dx is du over 2x plus 6. Now the integral becomes x plus 3 times square root u, because x squared plus 6x is u, times dx. Dx is du over 2x plus 6. Now we need to eliminate all x's. We have 2x plus 6 here and x plus 3. Can we simplify? Yes, because 2x plus 6 can be written as 2 times x plus 3 if we take 2 as a common factor. And then we simplify. We cancel x plus 3 and we get 2 in the denominator, so this is 1/2 times the integral of square root u du. But we know that square root u can be written as u to 1/2, and then we integrate. What is the integral of u to 1/2? It's u to 3/2. I mean, we add 1 to the power and divide by the new power. I mean, we can write it this way: 1/2 plus 1 over 1/2 plus 1 plus c, and then this is 1/2 u to 3/2 over 3/2 plus c, and then we can flip this because we have a fraction in the denominator. It becomes 2 here over 3 times 2, 6 u to 3/2 plus c, and that is 1/3. u is x squared plus 6x raised to power 3/2 plus c. another example. The integral of 2x over x minus 5 squared dx. The function is this expression inside the parentheses. As you can see, the function whose the substitution will be used is the function that's either inside the parentheses raised to some power, or inside square root, or a power. So these are indications of the function, the main function that we want to substitute it. So here u equals x minus 5, then du equals dx, because derivative of x is 1, and 1 times dx is dx. Now the integral becomes 2x over u squared times du. But here we have a problem. We need to eliminate all x's, but how can we eliminate this x? We don't have another x to eliminate it. Now if we have this situation, we need to go back to our substitution and rewrite the substitution in terms of u. So we use this substitution to find x, or to write x in terms of u. So u equals x minus 5, add 5 to both sides, you get x equals u plus 5. And then you put it here, and we get 2 times u plus 5 over u squared du. This is constant, we can pull it out of the integral. 2 times the integral of u plus 5 over u squared du. And then this is 2 times the integral. We can split the integral from here. It becomes integral of u over u squared du plus the integral of 5 over u squared du. Now we can cancel u, we get 1 over u here, but integral of 1 over u is natural log of the absolute value of u, plus here we have 5, we can bring it here, the integral, and bring u squared up here, it becomes u to negative 2 du. We have 2 times natural log of absolute value 5 of absolute value of u plus 5. Now what is the integral of u to negative 2? It's u to negative 2 plus 1 over negative 2 plus 1 plus c. Simplify more, we have 2 ln absolute value of u. Now this is negative 1, so minus 5, and this is u to negative 1. This is u to negative 1, so we can bring it down to get u to plus 1, so plus c. But we know that u is, from our substitution, u is x minus 5, so this becomes 2 times natural log absolute value x minus 5 minus 5 over x minus 5 plus c. Let's double check the steps. And here we have 2 natural log. Okay, and 2 times 5 is 10. Yeah. Okay, so this is the final answer. It's written in terms of x. Now we have some shortcuts from this method. We can find some shortcuts that can help us to find integrals in general. Sometimes we don't need to find to apply all the steps of the substitution method, so we can apply a result directly. For example, if you have the integral of some function of ax plus b dx, then this is 1 over a, because as you can see this is a linear function ax plus b, so 1 over a times the integral of f, or the antiderivative of f ax plus b. plus c. For example, you may see something like this. Integral of e to 2x plus 1 dx. Now this is ax plus b, so 1 over a, this is a and this is b, so 1 over 2. And what is the integral of the exponential function? It's the same exponential function. Also, if we have another example, the integral 3x minus 1 to the power 3 dx. So this is ax plus b. This is a constant. This is a linear function. So we can apply this rule. This is a. This is b. B is -1 in this case. So 1 over a 1/3 times the integral of this. The integral of this expression raised to the power 3 is expression raised to power 4 over 4 plus c. Also, one more useful shortcut is the following. If you have a derivative and an original function in the denominator, then this is natural log of the absolute value of the denominator plus c. For example, the integral of 1 over x dx, we know that this is natural log of the absolute value of the denominator, because as you can see, the numerator is the derivative of the denominator. So this is f prime and this is f. So this is natural log of absolute value of x plus c. Also, if you have integral of 1 over x plus 2 dx, as you can see, the numerator is derivative of the denominator. So this is f prime, this is f. The answer is natural log of the absolute value of the denominator.